Hello, everyone, and welcome to our second session of the Web and Mobile track. I'm very happy and excited to introduce our next speaker, Maciej, who is a cloud architect at Allegro Pay and also MVP, Microsoft MVP, is an inspiring person who started programming at the age of 5. So please join me in welcoming him. And hello, Maciej, and
Hi.
have a great session. And don't forget to ask questions on the Q&A chat if you have any, and participate.
All right.
Enjoy.
All right. So hi, everybody, and welcome to my session on application architecture for Kubernetes. And in this particular application, we'll focus exclusively on hosting and the application lifecycle. Okay, so you may wonder, why is this? So there's a huge hype for migrating applications from old infrastructure to Kubernetes without giving too much thought about how is it supposed to run. Let's just try to lift and shift it. And I've actually seen some of the migration processes end up as a disaster. And I thought it would be prudent to discuss the very basics of running your .NET application in Kubernetes. In other words, before we start running, we'll essentially learn to walk. So a little bit about myself. My name is Maciej Misztal. There's a Twitter handle in the bottom left. Feel free to reach out to me on Twitter or LinkedIn. I am also one of the co-leaders of the Warsaw.NET meetup group. So we're available on YouTube if anybody's interested. I've also been awarded the Microsoft MVP award a while ago. And in case you're wondering what's my typical tech stack that I work with, or I'm very, very passionate about, you can pretty much identify it by looking at those icons. The entire code from this presentation will be available on GitHub under my personal profile in a repo called K8s-hosting. K8s is a common abbreviation for Kubernetes. Okay, so .NET 6 is out, has been for a while. So in case you've missed it, we'll do a quick recap on what's new in the application hosting itself. So up until now, up until .NET 5, this is typically what our program CS used to look like. So what would happen is we would create the so-called host builder, build it, and run it. And what's important to note here in line 17 is that we would make use of a so-called startup class in which we would make container registrations and compose our applications pipeline. So all of this was nice until .NET 6, in which a plethora of new features have arrived, including a new way to quickly build your application and run it again. So what we have here is a web application builder, and essentially what's happened is the contents of the startup class have been dumped into program CS. So all the things that typically happen in startup CS, service registration, etc., happens up until line 10, and after line 10, the application pipeline is composed, and finally the application is run. So the hosting API has been evolving for a while. So in .NET Core 2.x, we used to have webhost create default builder. In .NET Core 3 and .NET 5, Microsoft has created a generic host. And in .NET 6, we have this new web application create builder. So like we've mentioned before, initially we create the web application builder, perform application and DI registrations, build the app and compose the pipeline, and finally run it. Interestingly, the run, at least at the time when I was making this presentation, does not contain an async override. So you cannot pass an external cancellation token into it. In some scenarios, you might want to do this, for instance, controlling application startup and shutdown in automated tests. At least that's my personal preference. So the question that comes to mind is, do we have to use the new API? No, we don't. It's actually actually perfectly legal to use the old API to create your application and use a startup class. It's even possible to bypass the startup class while using the old API. Okay, so there's that. And now let's move on to the fascinating world of Kubernetes. So we're going to discuss integration between Kubernetes and your .NET application. So first and foremost, we need to ask ourselves, how does Kubernetes know that my application is running, that it's ready to accept traffic, that it's started? So Kubernetes has the concept of the so-called probes, and at the moment there are three kinds of them. The startup probe is a probe used when your service takes a long time to start and initialize. For instance, you need to make a ton of DB queries just to populate a cache or something like that. So this is typically when you would utilize a startup probe. Once the startup probe's condition is satisfied, the liveness probe will kick in. Please note that the startup probe is completely optional. The liveness probe is pretty much a signal to the scheduler, I'm alive, please don't kill me. And it can take many forms. It can be an HTTP request to uh, a well-known endpoint that's sole purpose is to respond with an HTTP 200. It can be also done in other ways, like running a process inside a container and checking if a process is alive. So there are multiple ways to do it. And finally, the readiness probe. So the readiness probe is pretty much the indication that the service is ready to accept traffic. And this is often mixed with the application's health checks. But I personally would not advise using health checks exclusively for that. There are other factors that may be in play. There might be some conditions in which you may wish for an instance of your application not to accept traffic, for instance, when you're being under too much load and you would rather return HTTP 429 instead. So you could also utilize the readiness probe to signal the scheduler that, hey, I do not want to handle any traffic right now. I've got enough on my plate as it is. And when it comes to defining them, here's an example of how you can define the startup probe and the liveness probe. In this particular example, they map both to the same endpoint running on the same port. Uh, and the startup probe is configured to uh, run for up to 30 consecutive failures at the interval of 10 seconds. So that's 300 seconds total, so 5 minutes. And the liveness probe is far less generous than that. As soon as it fails, the scheduler is basically going to headshot your pod, and the replication controller will do its work of ensuring that there's a constant number of replicas up and running, and will provision the pod again. Okay. We've mentioned the startup probe, but how do we handle applications that take a long time to start from the application's perspective? So ASP.NET Core does not support this out of the box, does it? And actually, there is a way. And by the way, if you see a link in the bottom, I've managed to obtain some fantastic reads if you're willing to explore the topic any further. So if you've been following the changes made to ASP.NET Core around the time of ASP.NET Core 3.x, a change was made, and the hosted service executor, start async, was moved in front of the server start async, meaning that before the server itself starts and starts listening and accepting connections and handling them, all registered I-hosted services would be executed. So this is actually quite useful because we could have an I-hosted service, which sole purpose is to run any any logic that's supposed to initialize the service. And if you put some more effort into it, you could make that into a basically a tool which could look up custom I-hosted startup service registrations. So here's an idea for you, and would make sure that they're all executed in order to complete the startup cycle. And then it should signal your startup probe that, hey, I'm started, I'm done. So let's move on to the liveness probe. All right, so next up that we need to discuss is the shutdown. So what happens during shutdown is actually not that obvious. So let's try to discuss what's happening here. So once we tell Kubernetes, hey, delete this pod, so I'm going to type in kubectl dash namespace and provide the namespace name, delete pod, and followed by the pod name. The request will be sent to the API server, and two parallel processes which do not have any synchronization between themselves will start. So first, a notification of deletion will be sent to the kubelet, and the kubelet will start stopping the containers. There's also a concept called the grace period, during which nothing is supposed to happen. This is the time given by Kubernetes to the application to stop gracefully. So that was A1 and A2, and at the same time, we'll focus on the B track. So the pod deletion notification is sent to the endpoints controller, and that pod is deleted from the endpoints list. And finally, once that's done, the notification is sent to kube proxies, and IB tables in the entire cluster are updated to reflect that change, that the pod has been removed. So this will effectively stop any new connections from being made to that pod. But until that happens, it is possible. So how do we deal with that? We'll discuss that shortly. So also let's focus a bit on the A track again. So once the API server tells the kubelet, hey, delete that pod, the first thing that happens is the kubelet sends the sigterm signal to all of the containers running in the pod. So this is pretty much the signal telling, hey, you've got a little time to complete your processing and shut down gracefully. Otherwise, I'm going to, well, not be as gentle as you'd like, and I'm going to send a sick kill instead, telling you to terminate immediately with all potential consequences. At the same time, like we've discussed, what's happening is the endpoint controller is being updated independently of that termination process. Okay, so let's focus a bit on connections. So as you can see, there's a connection with a request pending at the end. While that request is being processed, a sigterm is being sent. And there's a few seconds delay before the IP tables rules are updated on all nodes and new connections are stopped from being accepted. And here the inactive and keep alive connections are being terminated. And finally, all the last active requests should complete. And this is when the service should terminate immediately. This graphic is taken from one of the best books on the market in regards of Kubernetes, and it's provided by the Manning Publishing Company. I highly recommend you take a look at their book. It's fantastic. It's done wonders to me. So what we should deduce from what we just said is that on the application side, we need to wait until the IP tables are updated everywhere and the app does not handle any connections anymore. So what we could do is we could hook into the application stopping lifecycle hook and do a sleep. But to be honest, is this really the best way to do it? it's a good way to do it on a .NET app, but what if you're running Python apps, Node.js apps, .NET apps, Java apps? Uh, Maybe you'd prefer something far more generic, a solution that will work everywhere. So you may or may not know it, but pods have a so-called lifecycle hooks, and one of those hooks is a pre-stop hook. So if you execute a simple bash command, sleep for 5 seconds, it will do the trick. It will give you the time needed to update the IP tables and ensure that no new connections are being accepted. And it will work everywhere. So in other words, what just happened? Uh, we've made sure that no new incoming connections uh, would be possible before pre-stop would be executed. Okay, so once we're at this point, so how do we safely drain the service? I mean, there are still some requests in flight, and we would rather prefer to have them completed successfully because, for instance, if we're processing some, let's say, payment data, we wouldn't want to end up in a situation when a request was terminated in the middle of execution and suddenly we didn't know what happened because the process was terminated. Okay, so what we can do is we can introduce an active request middleware into our pipeline. And the sole purpose of that middleware is to ensure that every single request is being added to the request counter. And that request counter is hidden inside the iActive request service. So the active request service is quite simple. It has the counter and uses the interlocked increment and decrement to update the value of the counter from multiple requests without using any synchronization primitives. It's a highly performant way of doing such things, but please be careful when doing that because you may end up shooting yourself in the foot if you use this carelessly. Okay, so we know that we have a way of tracking how many requests is the service currently handling. So how do we shut down? So we can introduce an I-hosted service which is dedicated to that purpose. So once that service starts in the start async method, we pretty much register an execute graceful shutdown handler with a default timeout in seconds. And what this execute graceful shutdown handler will do, it's going to try wait until either the service has no active requests anymore or the timeout expires. And for that purpose, I've created a very simple uh, async extension method, which works pretty much like this. So there's a func delegate with a condition, there's a probing frequency that we can externally provide, and the actual timeout. So what happens is we create the wait task, which is going to run checking the condition in a loop at the preset frequency. And finally, there's a task when any, and we provide two tasks, the original wait task and the task delay of timeout. So if our wait task is not the task that's returned by when any, so it means that it wasn't the one that completed first, we're going to get a timeout exception. And that's pretty much it. Okay, so we've discussed startup and we have discussed shutdown. And what else do we need? So to be honest, when running such applications on Kubernetes, what we require is a standardized pipeline, which will standardize the service behavior irregardless of the workload type. So I don't want to worry if it's a RESTful service, if it's a minimal API service or a controller service or a gRPC or a GraphQL service. I want it to become I want it to behave in the same predictable way. So you can use such constructs to ensure that. And also when it comes to composing the application pipeline, uh, you want to make sure that your liveness middleware is in front. It needs to respond as quickly as possible to the actual liveness probe requests. You can have a metrics middleware, you can have a startup middleware that will determine whether or not your application is successfully started. You can have a readiness middleware that is dedicated to responding solely to the readiness probe. And finally, you have all the typical middlewares you would have, like authorization and the actual request handler. In this talk, we haven't really talked about handling async traffic like service bus handlers, but essentially what you want to do is pretty much the same. You want to ensure that you keep track of messages that you're handling and you want to drain them safely as well. Um, oh, and a side note that just came to my mind, you may wish to explore a project called Dapper. One of the things I like about Dapper is that it, uh, the Dapper project can be found under dapr.io. So one of the things I actually liked about Dapper was the fact that when you use its pops up mechanic to connect to a service bus, what it will do, it will actually transpose all the service bus messages into actual HTTP pipeline messages. So you could technically reuse those primitives that we just discussed to safely drain a Dapper service. Okay, that's probably it. It's now time for a short demo. So for that purpose, I'm going to show you. Okay, so this is my instance of Visual Studio, and let's start the .NET service. So the service is starting, and what I want to do is I want to show you guys to this side that it's running, and over here I want to show you guys that I have it. So it has a single well-known endpoint called the weather forecast. And you can see that it handles the request and has a small sleep timer. So it will randomly wait for a short period of time to simulate that the processing is taking a while. It also has the liveness probe endpoint, in which I'm actually returning some basic service metadata, like what's the name of the service, what's the pipeline mode in which I've configured it, what's the ID of the service instance, what are the packages that make up this service, and what versions are they that can actually be pretty useful in production scenarios. There's also a similar readiness probe, so it indicates that the service is both ready and started, and the startup probe. So yeah, so this is just information about the startup itself. So let's now try to simulate some traffic. So there are 7 active requests. Now I press Ctrl C, SIGTERM has been sent, and the async mechanic has kicked in. It's probing 4 times a second and waits until the application is drained successfully. And now the application has stopped. So this is the very behavior you would expect from the service running in Kubernetes in order to have it shut down in a stable, predictable way. So I've mentioned that I would like to have this behavior irregardless of the workload type that I'm using. And I also have prepared for you a demo GraphQL service. So here's my GraphQL service. So what you see in the right is the so-called GraphQL Voyager. So you could think that GraphQL Voyager is to GraphQL what Swagger is to a RESTful service. So very basically, it describes the schema. However, um, in order to show this demo successfully, I will need to use Postman. So I'm just gonna do that. So here it is, and here's Postman. So let's make sure that everything works. Yay, we got a schema response. So now let's run the actual query. So we're querying for books, title, offers, and the weather forecast because I might wish to read a C# book on a sunny day because, well, what's not to like? And as you can see, if I send a request, the same mechanics kick in, although Postman is considerably slower when sending multiple requests. So I will not be able to demonstrate that drain mechanic. However, it behaves very much in the same way. Okay, so I believe it's now time for a brief Q&A session. So uh, I'll be, I'm reading the Q&A chat. Okay, so I see two questions in the Q&A chat. The first question is why in .NET Core 3 and 5 we have the more generic host, but in 6 we move back to a specific web host builder. So yeah, so that was a design decision made at Microsoft, but like I mentioned, they do not force you to use the web host builder, but they provide it as a simple to use default. If you would like to run a more advanced scenario where you require far more control, in this case, you would prefer to use the legacy API. So I hope that the answer to your question was satisfactory. Can you please explain why should we not use or use carefully health checks provided with the .NET app? Also, what about Azure App Service health checks self-healing functionality in conjunction with K8s? So it's actually two questions. I'm going to try to focus on the first part first. So, Ratko, like I've mentioned during the talk, there may be more than a single factor that comes to play when dealing with readiness probes. It may not be just the health checks. Maybe you want to continue serving traffic under certain conditions. For instance, you've lost write capability, but you still can perform reads from a cache. So no reason for your service to be totally unavailable. So that's a scenario that comes to mind. Also, like I've mentioned in the talk, there can be other factors such as the service being under too much load. So that's another factor you might want to bring into the readiness probe itself. And regarding the second part of your question, what about Azure App Service Health Check self-healing functionality in conjunction with KS? Unfortunately, I'm not sure I understand the question. I'm not familiar with that functionality. It's been a long while since I've used the Azure App Service, but I'll try to follow up on that question and maybe try to answer this on Twitter later. So I hope you're satisfied. When would you want Kubernetes set up instead of single serverless functions? Oh, that's a good question. Okay, so first and foremost, let's compare the ideologies behind running the services in both ways. So serverless workloads were created for short workloads that last a short time and consume little resources and are cheap to run, provided you don't use them too much. But as your traffic increases, there may be an economical threshold at which running a serverless service may not be feasible anymore, and maybe you will start preferring to use something that's actually running 24/7. So at that time, you may wish to consider something like an Azure Application App Service. But if you need something more, you could say, exquisite, then Kubernetes might be the right answer for you. So this is for workloads in which you want to have the capability to auto-scale your infrastructure, your workloads, both horizontally and vertically, and also for more advanced scenarios like um, running their workload in multiple regions, performing advanced connectivity scenarios, advanced deployment scenarios like canary deployments, blue-green deployments, rolling updates. So things like other hosting methods do not necessarily support. For instance, as far as I recall, in Azure App Service, the safe way to do a production deployment is to use deployment slots, where you would update a deployment slot with the latest version of your artifact, test it, and then perform a hot swap on the slots themselves. Uh, so in Kubernetes, you can, well, there's more than one way to skin a cat. And while skinning the cat, you can also control the traffic flow. So this leads to interesting scenarios for testing, for instance. So I hope your question was answered. Uh, are there any more questions? Yeah, I'm monitoring the chat, but nothing new pops up at the moment. Okay, Karen, I guess there are no more questions to be answered. So
Thank
I
you
think
very
that's
much.
it.
Thank you
Yep.
very much for your session. I have a few questions of my own.
Yeah, go ahead.
So I wanted to know, like, I read your bio and I saw that you have experience in so many languages, Python, C Sharp, C++, like.
Fortran, don't forget Fortran.
So I was wondering, what is your favorite one or the
Oh,
top three?
I think the language I feel most comfortable in is actually C Sharp, but unfortunately, recently, most of my time has been spent in PowerShell.
I
It
see.
impaired .NET Cousin.
And can I ask what attracted you to DevOps?
Necessity, because nobody else had the guts to do it. And there's a terrible shortage of people with that sort of experience who are not afraid to get out of their comfort zone and integrate, configure, secure things, and, well, break them. So yeah, developers are typically folks which are pretty content when they are sitting in their safe space. They just want to focus on uh, doing their job in the best way possible and not necessarily take on any more responsibility. I respect that. However, in my case, experience proved to be different.
I see. So, as I mentioned before, you started programming at the age of 5, which is really, really
Yes,
inspiring.
at the age of 5 in 1985, my father brought back home a tiny black keyboard with a small rainbow in one of the corners. So that was a Sinclair ZX Spectrum, and was starting to teach me BASIC at the age of 5. We were
That's
doing some
amazing.
binary, and uh, he wrote 11 on a piece of paper and asked me, how much is this? And me at the age of 5 was like, free. And my
Wow.
mother's look was the greatest. What fuck of all time.
I see. So what is your next language you're going to learn, or framework, or whatever?
Oh, I've been dying to um, spend some more time in Python or F sharp, but unfortunately, I rarely get the opportunity to do so. But I also feel a strong drive to um, do some mobile applications again, because I used to do Windows Phone back in the day. And right now, Flutter and Dart seem like a cool option to, well, explore this world. And while learning this technology, I actually start to feel the joy of coding again. I'm doing stuff, I'm breaking things. It's cool.
That's our job, right? To enter
Yes.
bugs and to production and stuff like that.
Yeah, precisely.
And do you have some tip or advice for like to how to learn a new language, to how to get started?
Oh,
Share your experience.
yes. I think, at least from my personal experience, uh, I- I've tried using numerous sources of information because I'm self-taught mostly. And what worked for me best for a while was reading blogs, then it stopped working, then watching videos, but that stopped working even quicker. For me, the best way to learn things is by doing. So you won't learn anything until you have to solve a specific problem and you have to sit down, roll your sleeves up, and get your hands dirty. This is when you learn, and this has been proven to be bulletproof for, well, the majority of my career.
Yeah. So thank you very much for
Yeah.
sharing your
So
knowledge and
the final
experience.
tip when you want to learn something, for instance, write a service in Node.js
Mhm.
or make a mobile app, set a goal, write yourself some acceptance criteria. What would be the solution that you would expect with the level of quality that you would expect? And try to live up to that standard the best way possible. You may not make it initially, but hey, it's, well, you seldomly succeed 100% on the first attempt, right?
Okay. Great. Thank you very much. Thank
Thank
you
you.
all for attending this session. I wanted to remind you that you have a chance to win ebook by thanks to our partner Pact. And just keep participating, give your feedback, and ask questions. And most importantly, enjoy this day and learn something new. Goodbye, everyone.
See you
Thank
guys. Enjoy the
you.
conference.